In this problem, we're going to use derivatives to find all our maxes, mins, and inflection points for the following function. And then we'll take a look graphically to see if everything matches up. First thing we're going to do is take our derivative. So taking the derivative here, we get 3x squared plus 6x minus 9. And let's go ahead and set that to 0. And we can factor. If we pull out a 3, we get x squared plus 2x minus 3 equals 0. And this will factor as well into x plus 3 times x minus 1. So right off the bat, we can see that we've got two critical points at -3 and 1. And we can test these using the first or the second derivative tests because we're looking for maxes and mins. Since we need the second derivative anyways, let's go ahead and just use the second derivative test. So the first thing we need is the second derivative, which again is just piece by piece. It's going to be 6x plus 6. And we'll set that to 0 because we want to find any inflection points. So we have 6 times x plus 1 equals 0. So x equals -1 is going to be where we might have an inflection point. Alright, now first let's go and check these and see if we have maxes or mins. And the way we do that is we evaluate each one at the second derivative to see if it's positive or negative. F double prime of -3. If I were to put a -3 in here, I get -18 plus 6, which is a negative number. So remember, if the second derivative is negative, just as a reminder, that means it's concave down, which means I have a max. So I have a relative max at x equals -3. And we'll find that as a point in just a second. F double prime of 1, just to verify. Notice we'll have 6 plus 6, which is 12. So let's just use this. It's greater than 0. Means it would be concave up. Means we have a min. So we have a relative min at x equals 1. Now because they ask for a relative, these local maxes and local mins, which is also a relative max or a relative min, I sometimes use those terms interchangeably. We will give them as points, and our inflection point, if we have one, is at -1. Well, if we were to make a number line and put -1 on it and check our derivative, notice if we were to put in 0, we get a positive. If we were to put in, say, -2, we'd get a negative. So our original function, this is f double prime we're testing up here, our original function would be concave down, concave up. So we have an inflection point at x equals -1. Now we need to find these as points, and so what I'm going to do is I'm going to use the calculator to help us out here. And so I've got my function in here, and I have my table. I'm going to change the independent to ask. This is something that you can do to find a few values quickly. And when I go to my table, I needed a value for -3, and 1, and -1, and there are my values. So my relative max is the point -3, 12. My relative min is the point not -1, that was for our inflection point, 1, -20. Our inflection point is at the point -1, -4. Now that we have this graph, let's confirm this graphically. We can see that to see this thing, we're going to need the window to go down to at least -20 and up to at least 12. So let's give ourselves some room. And I accidentally changed the wrong setting. I meant to do the y max. Let's keep that at -10. We wanted the y max at 15. So you see there we got a relative max at -3. It goes up to 12. Our inflection point, it's hard to sometimes pinpoint on a graph, but it looks like it's about at -1 and with a y value of -4. And there's our relative min sitting here at 1, -20.